Hello, welcome to part 2 of graphing linear inequalities, and in this session we're going to actually look at linear programming. Linear programming is maximizing a different equation, so we're finding a maximum value. That's the goal here. We're looking for a maximum value, and we're going to be maximizing this function through these parameters. The first thing I want to do is I want to graph this system. But before I can do that, I need to solve my equations first. So we need to correct this system real quick. So I'm going to look at 5x plus 11y equals 88, and I want to get this to y equals mx plus b so I can graph it. So I'm going to subtract 5x from both sides. I'm going to end up with 11y equals negative 5x plus 88. Then I'm going to divide by 11 on both sides so that I get y equals negative 5/11 x plus 8. So let's make this one y equals negative 5/11 x plus 8. And this one's easy. This one, this is greater or less than or equal to. This equation's easy. It's going to be y is less than or equal to negative x plus 14. So now I go graph these guys. Here's my graph of the system right here. This is the equation 2. Negative 1x minus or plus 14. This is negative 5/8 x or 5/11 x plus 8. And then here are my y is greater than 0, x is greater than 0. So the values that we're looking at are all under this green and a little bit of purple line and then above it. So the next thing we need to do is to find the vertices or find where they all intersect. So my vertices are going to be where all of my constraints intersect to make the 4-point rectangle. So we're looking here, the origin, right here where the purple and green intersect, and right here. So my vertices are going to be 0, 0, 0. 0, 8, 14, 0, and we have 9, 3. Excuse me, 11, 3. Now the last thing we want to do is plug this into our given function. Plug each value into our given function. Our function is z equals 4x plus 5y. And we're actually looking for the maximum value of z. We're looking for the ordered pair that provides that. So we're going to plug 0, 0 in. 0 times x, or 0, excuse me, let's do this again. 4 times 0 plus 5 times 0. This equals 0. Let's plug 0, 8 in. 4 times 0 plus 5 times 8. 4 times 0 is 0. 5 times 8 is 40. This equals 40. Let's plug 14, 0 in. 4 times 14 plus 5 times 0. 4 times 14 is 56. 56 plus 0 is 56. And let's check 11, 3. 4 times 11 is 44. 5 times 3 is 15. 44 plus 15 is 56. Let's check 4 times 14 again. Yep, 56. So our maximum values are going to be these two. So our maximum value for z equals 5x, 4x plus 5y equals 56. Let's look at one more problem. Here it says find the maximum value of the function z equals 4x plus 2y. So the first thing I want to do is graph. In order to graph this, I need to solve for y, so I'm going to subtract 4x. Three y equals a negative 4x plus 56. Divide by 3. So y equals negative 4/3 x. 56 divided by 3 is going to be 1. 2 is left over, so we have 18 and 2/3. Now I want to graph this whole thing. Here is x is greater than 5, y is greater than or equal to 4, and then here is y is less than negative 4/3 plus 18 and 2/3, which is up here somewhere. Next I need to find my vertices. This is where my lines intersect. They intersect right here. Let's use a different color so we can see it. They intersect here at 5, comma, that's 10, 11, 12. So 5, 12, 5, 4, and 11, 4. So we had 5, 12, 5, 4, 11, 4. My function was 4x, z equals 4x plus 2y, and then I'm looking for a maximum value for z. So I'm going to have 4 times 5 plus 2 times 12. 20 plus 24 gives me 44. I have 5, 4, so I have 4 times 5, again. Plus 4 times 2. 20 plus 8 equals 28. 4 times 11 plus 2 times 4. 44 plus 8 gives me 52. So my maximum value here is 52. So just graph this, graph these equations, find your vertices, and then plug and chug.